So again, since this is a probability, okay, so it should be non-negative for all x. And if we integrate from negative infinity to positive infinity, then it must be 1, because from the axiom of probability, we know that total probability will be 1, right? So that is what the second bullet point talks about. Then is another related concept, which is expectations and variance. So the expectation of a random variable x denoted as that big E, and you put the x between the two brackets. This is a very useful measures for the central tendency of the distributions. Okay, so this is the average value of the how to say that? It's an average value with probability weighted averaging. Okay, so what does that mean? I think it would be good to start from a discrete type of random variable. So I just randomly made up one example here. Use the coin toss as an example. It says that we are going to play again here. If you flip the coin and you got the head, then I'm going to give you $10. So that's why I put 10 here. And if you have tails, then you have to give me $5. So that's why I have a -5 here. So what is the expectations of this random variable x, which is the potential money you can get from this game? So by the definition here, we put the probability, we weight the outcome, which is I should put the -5 here. -5. We weight outcome with the probability. Okay, so that's why I say it's a probability weighting average. Okay, and says that now the coin is a fair coin here, so it's like 50-50%. You will get head and tails. So you put 0.5 here and put 0.5 here, and finally you will get like 2.5 in the end. So this is the expected money you can get from this specific gain. Okay, and that is the concept of expectations or expected value of the random variable x. Okay, that is the discrete type of gain, or like the distribution or the random variable. And we can apply it to continuous distributed random variable as well. So the way we calculate it is we put the value here, x here, and then times the PDF, okay, the density f of x here, and then integral. Take the integral from -infinity to positive infinity. Okay. Right. So we have an important property here, meaning that this is actually a linear operations here. So if we plus a constant a and times a constant b in front of the random variable x, then you can actually take it out of the operations. Okay. Okay. And the most common error I made when I learned the expected value is that says that we have two random variable. So it is not always true. We can write it as the multiplications of two random variable. I mean the expected value. Okay. The multiplications of two random variables. So this is not always true. Okay. Okay. Just remember that. And if this y is a constant number, okay, b, then we can take it out. It's not a problem. So you have to be careful, okay, and distinguish these two. Okay, and another features of a distribution. I mean, the first one is the average. I mean, the expected value or mean. We can also call it mean as well. Another related concept or important features of distribution is variance, which means how far this distribution is going to deviate away from the mean. Okay, put it this way. So the mean or expected value is actually captured the central tendency, and the variance is to measure how far, like how spread this PDF is, would deviate from the central tendency mu here. So the way we calculate the variance is for all, is kind of like for all x, we minus, we subtract the mu from it, or like the mean from it, and then we take the square. Why do we need to take a square? Because if we didn't do that, then like positive side and negative side may cancel out with each other, right? So the way we put the square over there is to turn it into kind of like calculate the distance, right? If you remember the Euclidean distance, that is the way we calculate the distance. Okay, so we just put the square over there and take the expectations again, because we want to know kind of average. Each point will be away from the central tendency. Okay, so that is variance. And usually we'll put a sigma here to represent sigma square, represent variance of the random variable x. Okay, and sometimes it will be useful to use the positive rule here. So just put a sigma. That is standard deviation. Okay, so if you start to learn about inference, then you will use this standard deviation instead of variance. Okay. And then last term is covariance. So to talk about covariance, we have to have two random variables here, x and y, and that is kind of the interaction terms here. The way to calculate the covariance is x will minus the mean of x, and y will minus the mean of y, and you take the multiplication and then take the expectation again, right? So this is the